RD-180 will deliver more than 860,000 pounds of thrust to lift the vehicle off the launch pad. For those watching the broadcast, you're looking at video taken earlier this morning at Space Launch Complex 3. This is Atlas Mission Control at T-minus 4 minutes and holding. Preparations for this morning's launch are continuing. At this point, the team is not working any issues, and liftoff remains on schedule at 7:46:30 a.m. Pacific Time.
Roger.
The animation you'll see after liftoff is referred to as Satellite Toolkit or STK. STK uses real-time telemetry data during the flight to track the path of the launch vehicle beyond the range of ground-based cameras. While the team completes final preparations for launch, let's have a look at a preview of today's flight.
The following profile details the important events of this mission using approximate times.
6, 5, 4, 3, 2, 1, 0. Have ignition.
The Atlas RD-180 main engine ignites to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas-V reaches Mach 1, the speed of sound, at 77 seconds. At 85 seconds, the vehicle experiences maximum dynamic pressure. Approaching booster engine cutoff, the Atlas-V is burning propellant at a rate of 1,600 pounds per second, traveling at approximately 16,000 miles per hour and located 62 miles in altitude and 146 miles downrange. Booster engine cutoff occurs approximately 4 minutes after liftoff. 6 seconds after booster engine cutoff, the booster stage is jettisoned. The first Centaur main engine start takes place 10 seconds after booster separation. The payload fairing is jettisoned approximately 4.5 minutes into the flight. Centaur main engine cutoff occurs just over 15 minutes into the flight. At 18 minutes 28 seconds, Centaur releases DMSP for the United States Air Force.
This is Atlas Mission Control at T-minus 4 minutes and holding. We remain in the planned 20-minute hold as preparations for the launch continue. Launch Conductor Ward Johansson will pull the launch team in a few moments for the final go to resume the launch countdown. 29 engineers and managers will be pulled for system status and readiness to proceed with the launch. This is the final status check before launch for all Atlas vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Western Range. The readiness poll includes hydraulics, pad water deluge system, electrical systems, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Launch Conductor Ward Johansson performs the final polling of the team in a few minutes.
L-minus 10 minutes.
RC verify solar radiation acceptable for launch. Verified. LC switch to ready position. All steps complete prior to the status check. Status check to proceed with terminal count. Atlas systems, propulsion. Go. Hydraulics. Go. Pneumatics. Go. LO2. Go. Water. Go. Centaur systems, propulsion. Go. Pneumatics. Go. LO2. Go. LH2. Go. HASGAS. Go. Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
Instrumentation.
Go.
COM.
Go.
Timer.
Go.
GCQ.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Range coordinator. Clear to proceed. Launch director.
Launch vehicle is ready to launch.
Mission director.
This is the mission director. You have permission to launch.
Proceeding with the count. Verified T0 is set for 14:46:30 Zulu.
Roger.
Polling is complete and the launch team has given the go for launch. The countdown will resume approximately 2 minutes from now. From T-minus 4 minutes until launch, you will be listening to Launch Conductor Ward Johansson and his team performing the final steps in the countdown procedure. Atlas LO2 topping activity is secured at T-minus 3 minutes. At T-minus 2 minutes, the team will transfer the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute 55 seconds, the team will command the launch sequencer to start, followed shortly by securing the Centaur LH2 and LO2 topping activity. The flight control system is commanded to launch enable, and the flight termination system is armed at T-minus 1 minute 40 seconds. 1 minute later, the Atlas tanks will be verified at flight pressures, followed with verification of the Centaur tank pressures at T-minus 30 seconds. A final status check of Atlas, Centaur, and DMSP 19 readiness is conducted at T-minus 25 seconds. At T-minus 3 seconds, the RD-180 engine will roar to life.
On my mark, the time will be T-minus 4 minutes and counting. 3, 2, 1, mark. .355.
Ground power is in.
This is Atlas Mission Control at T-minus 3 minutes, 50 seconds and counting. The countdown clock has resumed and we are go for launch at 7:46:30 a.m. Pacific Time.
.3 minutes.
Securing LO2 topping. Atlas tank, the flight pressure.
.250.
FTS internal.
T-minus 2 minutes, 30 seconds and counting. The countdown is on track as we proceed toward T0.
.159.
Vehicle internal.
.155.
Launch sequencer start.
.150.
Securing Centaur LH2. Securing Centaur LO2.
.140.
Launch enabled.
.137.
FTS armed.
T-minus 1 minute, 30 seconds and counting. The launch vehicle, payload, ground systems, and Western Range are go for launch.
.120.
Orca's armed.
FTS count started.
.115. .110.
Vent valves locked.
T-minus 1 minute and counting.
Rock, range is green.
40.
Stable at step 3.
28. 25.
Status check.
Go Atlas.
Go Centaur.
Go DMSP.
Thirteen.
T-minus 10,
10.
9, 8, 7, 6, 5, 4, 3, 2. We have ignition and liftoff of the United Launch Alliance Atlas-V rocket carrying the Defense Meteorological Satellite Program mission for the United States Air Force. You are hearing the voice of Marty Malinowski providing launch vehicle ascent data. Let's listen in for mission progress.
Route control on the EU system. Injector pressures, pump speeds look good. Booster engine continues to operate well. The pitch program is complete, now flying the zero angle of attack phase of flight. Body rates look good. Bus and battery voltages are stable. Mach 1. Max Q. And booster has throttled down as expected. Current altitude is 9.8 miles, downrange distance 2.5 miles. Current velocity is 1,360 miles per hour. Booster engine continues to look very good. Body rates are controlling right down the middle. Injector pressures, pump speeds, right within band. And closed loop steering has been enabled. And we have fired the RCS pyro valve. Signatures look good. Starting to ramp up to pressures now for that system. Currently accelerating at 2.9 Gs. Altitude is 34 miles. Downrange distance 36.5 miles. Current velocity is 3,876 miles per hour. Q alpha limited steering is completed. And booster has throttled back again, right on schedule. Engine response looks good. Coming up on our 5G throttle segment, currently accelerating through 4.7 Gs. Bus and battery voltages look good. Boost phase cooldown is underway. Pump temperatures look good. Currently throttling to maintain 5 Gs. And we've throttled back to our 4.6 G throttle segment. Boost phase cooldown is complete. And we have BECO, engine shutdown looks good. We have retros and stage separation. Looks like a clean SIP. LOX and fuel pre-start. are underway. GN2 purge firing of the RCS is complete. We have ignition and full thrust on the RL-10. Coming up on payload firing jettison momentarily, and we have jettison. And Centaur has begun closed loop steering. Body rates look good. LO2 tank pressures have vented down as expected.
This is Atlas Mission Control at T plus 40 minutes, 52 seconds into the flight. We've just heard Marty Malinowski report the successful execution of events comprising the early part of today's mission, and all systems continue to operate nominally. Our next event, Centaur main engine cutoff, will occur in approximately 11 minutes. I'm joined now by Lieutenant Kathleen Rhodes from the U.S. Air Force Defense Weather Systems Directorate. Lieutenant Rhodes, thanks so much for joining us this morning.
Thanks, Matt. It's a pleasure to be here.
So can you tell us a little bit about how DMSP fits within the overall nation's space portfolio?
Absolutely. DMSP-19 will observe Earth's land and sea areas, including soil moisture, snow cover, albedo or earth shine, ice, dust, and sea surface winds. DMSP-19 will also observe the Earth's atmosphere as well as space weather. DMSP sensors provide imagery in visible, infrared, and microwave bands to enhance information available to the warfighter. Through these satellites, military users find, track, and forecast weather systems over remote and hostile areas for deployed troops.
So obviously DMS plays an important role in that overall portfolio, but what are some of the unique capabilities and features of the DMSP constellation?
DMSP has two primary sensors, the Operational Line Scan System, OLS, and the Special Sensor Microwave Imager Sounder, SSMIS, both built by Northrop Grumman. The OLS provides visible and infrared cloud data, with each scan covering an area of 1,800 miles. The instrument is able to cover the entire Earth in about 12 hours. The SSMIS detects precipitation, surface temperature, soil moisture, and provides all-weather capability for worldwide tactical operations and is particularly useful in typing and forecasting severe storm activity. The spacecraft also carries a suite of additional sensors which collect a broad range of meteorological and space environmental data for forecasting and analysis. DMSP-19 will join the DMSP constellation, providing world-class space-based terrestrial and space weather data to support U.S. forces and its allies around the globe. The DMSP satellites operate in a sun-synchronous polar orbit about 847 kilometers above the Earth. The nature of the polar orbit means the satellite is able to observe any place on Earth twice each day due to the Earth rotating beneath the fixed orbits. DMSP will continuously collect data as it orbits the Earth. The satellite is always collecting imagery of cloud coverage as well as atmospheric moisture, temperature, and other data.
So that's a lot of capability that DMSP provides. How many satellites are there in the constellation?
Well, in its 50-year history, 41 satellites have been successfully launched. With today's launch, DMSP-19 will join a constellation of 6 other DMSP satellites. In conjunction with the other national agencies, DMSP has been instrumental in the development of meteorological technologies and continues to provide relevant, actionable information for modern military operations. DMSP is the longest-running production satellite program ever. DMSP satellites have saved billions of dollars and countless human lives as a result of timely weather forecasts.
That's quite an illustrious history for the program, and obviously it's been invaluable to the Air Force as well as to the warfighter. Are there any things that you can describe for us as far as how that affects our daily lives?
Well, through this constellation, military weather forecasters can detect developing patterns of weather and track existing weather systems over remote areas. DMSP also alerts civil and military communities of anticipated hazards in space to satellites and personnel. Weather forecasters use DMSP data to predict regional and global weather patterns, including severe thunderstorms, hurricanes, and typhoons.
Well, thank you. I mean, that's a good overview of the overall program. As far as yourself, or if we have any younger viewers that are watching that are interested in maybe a career in science, technology, engineering, or math, tell us a little bit about your background.
I've always been interested in math, from playing card games that involve math to taking various math courses. It's been a passion of mine. So I decided to pursue a math degree at the University of Maryland, Eastern Shore.
So how did that lead you to the Air Force?
Well, shortly after enrolling at UMD, my brother enlisted in the Air Force, and it was at his graduation that I witnessed the sense of pride and honor that was instilled in my brother and his fellow airmen. Seeing my brother graduate ignited my interest in becoming an officer. I decided to complete my undergraduate degree and commission in the Air Force. My career in the Air Force has been nothing short of amazing. I'm a project manager and have had many opportunities presented to me because of the military. I've been able to oversee DoD projects that directly help the warfighter. I go to work each day knowing that the work I accomplish serves a higher purpose.
Lieutenant Rhodes, I really appreciate you being here to provide us some insights into the DMSP program.
Thank you.
This is Atlas Mission Control. We're at T plus 10 minutes into today's flight, and all systems continue to operate nominally. Our next event, the first Centaur main engine cutoff, or MECO 1, is scheduled to take place in about 5 minutes. While we wait for our next event, let's take a look at some of the events that led us to where we are today.
Another Air Force satellite system is making daily contributions to the lives of every American. The Defense Meteorological Satellite System routinely provides its military weather pictures to the public.
For the past 50 years, the Defense Meteorological Satellite Program, DMSP satellites, have fulfilled the military's most critical requirements for global atmospheric, oceanic, terrestrial, and space environment information. Through these satellites, military users find, track, and forecast weather systems over remote and hostile areas for deployed troops.
We've had a long-standing partnership with the U.S. Air Force dating back to the 1960s. We have delivered almost 50 satellites over 50 years.
Last August, an Air Force C-17 Globemaster III aircraft transported DMSP Flight 19 from Sunnyvale, California.
And here it is, the C-17 carrying the nation's next weather satellite for the United States Air Force touches down here at Vandenberg Air Force Base, California.
This is so exciting. We get to continue the proud tradition of flying DMSPs for the nation.
It was absolutely outstanding. We had a great team that transported it down. We're going to transport it to our payload integration test facility. And there we'll go through about a 7 to 9 month process where we'll actually do some final tests. It feels great to be actually out here and beginning this close to launching our satellite and actually putting our mission up into space.
Fantastic day all around, all coming together to bring this very important satellite to Vandenberg to continue weather operations for the nation.
DMSP's F-19 satellite has received comprehensive Service Life Extension Program modifications to address all known life-limiting factors and maximize on-orbit operations.
As far as acquisitions goes, this is like the most exciting thing you can do is to see something come to fruition.
I've worked the OLS, the primary sensor on the DMSP satellite, since 1972. It's a very rewarding program.
We've been working hand in hand with our contractors, with our aerospace personnel, with our Air Force team. Everyone has come together. Couldn't ask for a better team or a more solid team.
We've got a satellite up there right now that's been running continuously for 18 years. Been a very good investment for the country as far as providing weather and space environmental data.
Energy is sky high. I've got second lieutenants out here just graduated from the academy, all the way through my aerospace support who have been on this program for almost as long as the program itself. It's 52 years going. We are the longest running production satellite in the world.
It's very gratifying to me to see the younger generations coming on and being so interested and picking up so quickly on the stuff. It's a good thing.
We always remark on how incredible that is. We
right.
have lieutenants and these young airmen coming
That's
in
right.
with the responsibility they're given.
Oh yeah.
You've seen it through the years.
Oh yes, definitely.
And how does it make you feel to be a part of that team with the Air Force and the contractors and civilians?
Oh yeah, I mean, on this program, even compared to some other programs that I discussed with my colleagues, this program has a history of absolute cooperation and openness between the various co-contractors and the Air Force. It's a very good relationship of trust that's been built up over the years.
On the support side of being in the military, you don't get to see a lot of action that some of our warfighters do, but this is how we contribute to the fight. I know our warfighters are going to appreciate everything that this capability is going to give them. It's a rewarding experience to know that we're contributing in our own way to the fight.
Go DMSP Flight 19! Go DMSP!
This is Atlas Mission Control at T plus 14 minutes, 7 seconds. The mission continues as expected. MECO 1 is scheduled to take place in a couple minutes. Let's go back to Marty Malinowski.
Our all-10 performance continues to be stable, all within parameters for the set MR. Hydrazine line temperatures look good. Continue to see our thermal conditioning firings. 1 minute remaining in this burn. And Centaur should now be orbital. And we have MECO. Engine shutdown looks good. We have 4S settling on. We'll have a 2 minute 49 second coast to the spacecraft separation.
This is Atlas Mission Control at T plus 16 minutes, 4 seconds. Welcome back to live coverage of the Atlas-V launch of the DMSP-19 mission for the United States Air Force. Liftoff of the DMSP-19 mission occurred at 7:46:30 Pacific Daylight Time. Our next event, spacecraft separation, is scheduled to take place in approximately 2 minutes. I'm joined again by Lieutenant Rhodes from the U.S. Air Force. Lieutenant, liftoff and launch is obviously a very exciting time. Can you share with us a little bit of your emotions at this point?
I'm really excited to be a part of this special moment, as this launch is the culmination of years of hard work and dedication from countless contributors.
Well, thank you. I do really appreciate you being here to share your insights with the DMSP about the DMSP program and for your service to the country.
Thank you.
Now let's check back in on the mission. We are at T plus 16 minutes, 50 seconds. We're about a minute or so away from spacecraft separation. Let's go back to Marty Malinowski.
And Centaur has completed the turn to separation attitude. Centaur fuel tanks are being vented. That vent is complete. And we have spacecraft separation.
Lieutenant Rhodes, congratulations.
Thank you. Taking part in this special event is truly an experience that I'll never forget.
Well, thanks. I really do appreciate you being here. And we've just seen successful separation of the DMSP-19 satellite for the United States Air Force. We are currently 19 minutes into today's mission. Liftoff did occur at 7:46:30 a.m. Pacific Time this morning. I'd like to thank Marty Malinowski for his support of this morning's broadcast. I'd also like to thank Lieutenant Kathleen Rhodes from the United States Air Force Defense Weather Systems Directorate.
Matt, it was great to be here for this important milestone in the DMSP program. Go DMSP!
We'll conclude our live coverage this morning with a replay of this morning's liftoff. For more information, you can visit our website at www.ulalaunch.com. I'm Matt Donovan, and on behalf of the entire team, thank you for joining us this morning, and have a great day. 3, 2, we have ignition and liftoff of the United Launch Alliance Atlas-V rocket carrying the Defense Meteorological Satellite Program mission for the United States Air Force. You are hearing the voice of Marty Malinowski. a.m. Pacific Time.
Roger.
The animation you'll see after liftoff is referred to as Satellite Toolkit or STK. STK uses real-time telemetry data during the flight to track the path of the launch vehicle beyond the range of ground-based cameras. While the team completes final preparations for launch, let's have a look at a preview of today's flight.
The following profile details the important events of this mission using approximate times.
6, 5, 4, 3, 2, 1, 0. Have ignition.
The Atlas-V AV044 main engine ignites to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas-V reaches Mach 1, the speed of sound, at 77 seconds. At 85 seconds, the vehicle experiences maximum dynamic pressure. Approaching booster engine cutoff, the Atlas-V is burning propellant at a rate of 1,600 pounds.
RD-180 will deliver more than 860,000 pounds of thrust to lift the vehicle off the launch pad. For those watching the broadcast, you're looking at video taken earlier this morning at Space Launch Complex 3. This is Atlas Mission Control at T-minus 4 minutes and holding. Preparations for this morning's launch are continuing. At this point, the team is not working any issues, and liftoff remains on schedule at 7:46:30
per second, traveling at approximately 16,000 miles per hour and located 62 miles in altitude and 146 miles downrange. Booster engine cutoff occurs approximately 4 minutes after liftoff. 6 seconds after booster engine cutoff, the booster stage is jettisoned. The first Centaur main engine start takes place 10 seconds after booster separation. The payload fairing is jettisoned approximately 4.5 minutes into the flight. Centaur main engine cutoff occurs just over 15 minutes into the flight. At 18 minutes 28 seconds, Centaur releases DMSP for the United States Air Force.